Good morning, all of you. So, as we know, in last class we studied what is the main postulates of Dalton's atomic theory. What he taught and what he told us, like around 10 points I taught you. So, what is the properties of that one and everything. Now, can anyone read the last point? Anybody can read that last point? All of you. Yes, please. Atoms of the same element can combine in more than one ratio to form a compound. Yes or no, Mitatsri? Yes. So every point, like all the 10 points, Dalton's atomic theory. So he has told about what is the atoms, how it is atoms are present and all. And you remember, atoms takes part in chemical reaction. Always only atoms are involving in any chemical reaction, they become stable. So that is the only reason why the chemical reaction will take place, means because the atoms wants to become stable. That is the reason chemical reaction will take place. So during this chemical reaction, all of you remember, who will actually involving in chemical reaction means only the one of the subatomic particles of atoms, which we used to call as, what is the name called as, guys? What is the name of that one called as? Electrons. But by the time of Mr. John Dalton, we know only atoms. We don't know the particles of atoms called as electrons, protons, and as well as neutrons, which we are not going to study any discussion in this chapter. Only the next chapter only will study structure of atoms. Now we are studying only atoms and molecules. So, according to chapter 3, who is only involved in chemical reaction, everybody? Who is involving in chemical reaction? Atoms are involving in chemical reaction. The reason is to become stable in nature. That is the reason. Okay. So that is why Mr. John Dalton said so many things like atoms are identical, their size is different, mass is different, understanding they combine always in a whole number, they cannot exist independently, and always they will be neither be created nor be destroyed. Like that, so many postulates he has taught of Dalton's atomic theory. That is what important postulates of Dalton atomic theory will see. Now, according to John Dalton, a matter can be converted into, matter will be in 3 states. Can anybody tell me what is the matter will be in 3 states? All of you? You all knows that. Matter will be in 3 forms. That is what? Solid, liquid, and gas. So, according to John Dalton atomic theory, all the matter, whether it is a solid or liquid or gas, everything. So, as we know, every matter, according to John Dalton, either it is a solid matter or liquid matter or gas matter, doesn't matter. Everything is made up of. What it is made up of? Harish? All the things is made up of what? Made up of a small particles called as atoms. That is what? Very tiny particles known as atoms only. So whatever it is, if it is a solid or liquid or gas, doesn't matter. Everything is made with the tiny particles, atoms. Now, if you take the solids, can you tell me what is the basic difference between solid, liquid, and gas? Any one of you? Gokul, Aswin Balaji, Yuhan, Mitakshri. Basic difference between the solid, liquid, and gas. Yes, please. Yes, please. How the solids looks like, how the gases looks like, particles. Can you tell me particles? Where the particles are very close each other? Anyone?
Solids.
Solid. So the basic difference between solids, liquids, and gases. Please kindly remember, if you take any solid or liquid or gas, the basic difference is in solids, particles are closely packed. You can see particles are closely packed, and liquids, some particles having some spaces between them, the gaps you can see here, some spaces between them. And here if you take the gases, they're having large space between the particles, but everything is called as what, guys? What is that called as? Here also it is called as atoms only. Here also it is called as atoms only. And here also it is called as atoms only. So that is what Mr. John Dalton is saying. So according to his, every matter, whatever it is, either it is a solid or liquid or gas, everything is made up of a tiny particles called as what is? Tiny particles called as
atoms.
okay. Now, so in our today's class, we are going to prove what is the explanation of chemical combination by Dalton's atomic theory. So we are having totally 3 laws, but class 9th we will study only 2 laws. So what is the 2 laws? Anybody can tell? First law. What is the first law? Conservation of, yes, please. Conservation of mass. Law of conservation of mass. And what is the second law? Firstly, law of
Constant proportion.
or fixed proportion. All of you remember constant proportion or fixed proportion. So let us see how Mr. John Dalton Dalton's atomic theory will give the explanation of these 2 laws. So let us go with the first law. So please all of you keep heading. The explanation of, as we already kept heading, explanation of chemical combination by Dalton's atomic theory, laws of chemical combination by Dalton's atomic theory. First one is the explanation of the law of conservation of mass. Explanation of the law of conservation of mass. We already did the event that again we are studying. So let us see that explanation of law of conservation of mass. So now, according to Dalton's atomic theory, we remember every matter is made up of what, guys? Every matter is made up of what, everybody? Yes, please. Every matter is made up of what?
Atoms.
Atoms, smallest particles. But is it possible to subdivide the atom? Yes, please. Atoms itself the smallest particles which cannot be further divided. What is the first point? What is the first point in Dalton's atomic theory? Everybody read. First point, you are written in our classwork also. Akilan, Gokul, read the first point of Dalton's atomic theory. Actually read. Yes. All the matter is made up of very small particles called as what? Called
atoms.
As atoms. Okay, next second point. Read the second point, everybody.
Atoms cannot be divided.
Cannot be divided. That is what. So, atom itself is the smallest particle which cannot be further divided. Is it yes or no, Hari? And also we know that particles cannot be divided and cannot be destroyed during chemical reaction because of, according to the Daltons, chemical reaction is an atom. So during the, according to this Daltons, entire chemical reaction is like an atom. So atom cannot be destroyed, atom cannot be created, atom cannot be further divided. Always it is a smallest particle. So due to this reason, the mass remains constant. Mass remains constant during the chemical reaction. Do you understand, everybody? So according to the Daltons, entire chemical reaction is like an atom. So mass remains constant in chemical reaction. So that is what, how he is explaining the law of conservation of mass. So we can say that during any chemical reaction, the number of atoms of each element in reactant side and product side remain same or different. Mitakshri, Akilan, number of atoms in reactant side and number of atoms in product side remain same or different? That is what my question. Everybody?
Remain same, sir.
Remain same. So that is what the explanation given by the Dalton's atomic theory. He is to consider chemical reaction is an atom. Do you understanding? So because atoms are only taking place in the chemical reaction, which is trying to attain the stable in nature. So the number of atoms of an element in reactants and product side remains same. That is what you have to remember that. Okay. During a chemical reaction, number of atoms of each element in reactant side, reactants and products remains the same because as we know, according to Dalton, a chemical reaction is a what, guys? Chemical reaction means what, Hari? Chemical reaction is because of atoms. That is why Dalton is considered as chemical reaction means is atom. So that number of atoms is always remains constant. So let us take one example and verify it. So keep it decomposition of calcium carbonate. Decomposition. This reaction already I taught you. Decomposition of calcium carbonate. Calcium carbonate. So let us verify. All of you tell me what is the calcium carbonate formula? Everybody. Calcium carbonate. Yes,
CaCO3.
CaCO3. So calcium carbonate, if I heat, that is what decomposition we can say. Please remember, decomposition, it will lead to produce calcium oxide plus carbon dioxide. Is it okay, everyone? Yes, please. Now, you want to write calcium carbonate formula. What is the calcium carbonate formula? First we write like the word form, later I will write in the symbol form. We'll get calcium oxide plus carbon dioxide. Okay, now write the symbolic equations. What is the calcium carbonate formula, everybody? CaCO3. Okay, if I will heat, that is what decomposition will take place and it will give you calcium oxide plus carbon dioxide. So that is what you have to remember. So let us construct number of atoms in reactants and number of atoms in products. So all of you can take, what is the atoms? Tell me, what is the atoms present here? Mitakshri, Harish, Akilan, what is the atoms? Calcium is present, next carbon is present, next oxygen is present. So now let me take in the reactant side. Reactant side only CaCO3. Number of atoms in reactant side. Reactant, so CaCO3. Next, number of atoms in product side. Product side means all the things you have to consider. Means CaO plus CO2. Now tell me please, reactant side, calcium how many? All of you should tell. Reactant side how many calcium?
100.
Calcium how many?
1, sir.
1. Okay, carbon 1. And oxygen. Oxygen how many, Hari? 3. Okay.
Yes.
Yes. Now, product side, check it, everybody. What is the product side? Product side. CaO, calcium, 1 only. 1. And carbon dioxide, nothing is there. So 1 plus 0, which is equals to 1. Next. Carbon. Carbon, check it, guys. Here no carbon, but here 1 carbon. So 0 plus 1, which is equals to 1. Oxygens, verify, everybody. Oxygens, how many? Here 1 and here 2. So that 1 plus 2, which is equals to how much?
3, sir.
3. So there are 1 calcium atom and 1 carbon atom and 3 oxygen atoms in both reactant side and as well as product side. So that is why. So it is verification. It is the explanation of law of conservation of mass. So particular element, if we'll take, for example, calcium. Always the number of atoms in reactant side and number of atoms in product side remains constant. That is only is law of conservation of mass. So mass will never change, number of atoms also will never change any chemical reaction. Is it okay, guys? Yes, please.
Yes, sir.
Yes. So that is what you have to remember that. Okay. So this is the explanation given by Mr. John Dalton or Dalton's atomic theory for the law of conservation of mass. Any doubt, Mr. Akilan, Harini, Johan? No response at all. Okay. Any doubt, guys? Utakshri? Next. Complete it. If it is completed, next, the explanation of law of constant proportion. The explanation of law of constant proportion. Explanation of law of constant proportion. So let's start. Everyone? All of you? Now, observe very carefully. As per the postulates of Dalton's atomic theory, all of you read the next property. First three properties you read. What is the fourth property? All of you read. Fourth property, fifth property, and sixth property. Hari.
The atoms are of various kinds. There are as many kinds of atoms as are elements.
Atoms as are elements. So totally how many elements known to us till today? What is the number of elements? Divya?
118.
118 elements, so that 118 different atoms are there. Now, is it all the atoms are having same ratio, same mass, same size? Everyone?
No, sir.
No. So as per the postulates of Dalton's atomic theory, you can see we are having a point called as the ratio of different elements in a compound is always fixed. Means, as I already taught you, for example, water. If you take in anywhere in the world, always water is made up of what, guys? Water is made up of how many? 2 hydrogens and 1 oxygen. So anywhere you can check it, the same ratio. So the postulate number, all of you read the postulate number 8. What is that postulate number 8 and 9? Hurry. Read everybody loudly. What is the postulate number 8? The number and the kind of atoms in a given compound, always what it is, guys? The number and a given kind of atoms in a given compound, always what it is? Fixed. 8th point and 9th point. During chemical combination, atoms of different elements combine in small whole numbers to form the compounds. So always compounds will form by smallest whole numbers. So no big numbers and ratios and all will react in the chemical reaction. So during the formation of compounds, different elements are combined always in a fixed ratio. So that is only explanation of law of constant proportion. For example, if we take carbon element. So carbon element always consists of what atoms? Everybody? Carbon element, if I'll take. So it consists of what atoms? I'm asking. Everyone? It consists of what atoms?
Carbon atoms.
Carbon atoms. If we'll take oxygen, oxygen consists of what atoms? All of you? Oxygen. If I'll take oxygen atom contains, oxygen element. What it will contain, Amma? Oxygen element contains what?
Oxygen atoms.
Oxygen atom. Do you understand it? Now, carbon element contains carbon atom. Oxygen element contains oxygen atom. Now, carbon atom combines with one carbon atom. One carbon atom combines with two oxygen atoms. Two oxygen atoms. So we are going to get the product. What is that, anyone? Always they'll be in a fixed proportion. What is that, anybody? All of you, fixed proportion, and they'll form a compound. One carbon atom and two oxygen atom. What is a compound? Nobody knows.
Carbon dioxide.
One carbon atom and two oxygen atoms. What is that name called as?
Carbon dioxide.
Carbon dioxide. So always this ratio is remains constant or not? They always will be in a fixed proportion. Wherever you will go, the fixed proportion is always this one. So what is the mass ratio? Mitaksri, try to find the mass ratio. Can you tell me? Harish, Gokul, Akilan, everybody try to find the mass ratio. Let me see. 1 into 12 is to here 2 into 16. So here what will come? 12 is to 16 twos are 32. Can you tell me lowest number, lowest whole number? Where it will come? Mass ratios. Nobody knows. What is the carbon dioxide mass ratio? I'm asking, Mr. Hari.
3 is to 8, sir.
All of you. 3 is to. Everybody should tell me which table.
Please do it, sir.
Which table?
Please change.
Fourth table. Understanding? By 4 we have to divide lowest possible both numbers. So 4 ones are 4 threes are 4 ones are 4 eights are. So now 3 is to 8. Is it possible to divide further? No. So what is the smallest ratio? What is the mass ratio? Mass ratio of carbon dioxide is 3 is to 8. Means in a given mass, suppose if I have given 1 kg carbon dioxide, in that how much oxygen and how much carbon? Anybody? Everyone. 3 by 11 is carbon and 8 by 11 is how much array? Who is? 8 by 11 is? Tell me total. Oxygen. Understand, Mitaksri, Divya? 8 by 11 is oxygen weight or mass and 3 by 11 is carbon mass. Is it okay, everybody? Yes, please. Yes. So this is proving that always if you take anywhere in the universe, always the carbon dioxide mass ratio is 3 is to 8, and understanding their number. What is the atom ratio? Atom ratio how much? Atoms ratio I'm asking. Atoms ratio, tell me guys. Carbon how many? 1 and oxygen always 2. That is what the ratio of atoms. 1 carbon and 2 oxygens only can produce carbon dioxide. So this ratio is always remains constant. So it will prove that this is a law of constant composition, or we can say constant proportion. So that is what you have to remember. So that is how the explanation is that Dalton's atomic theory is giving the explanation for law of conservation of mass and as well as law of constant proportion, or what is another name of constant proportion? Everybody? Fixed proportion. Don't get confused. Law of constant proportion, or we can say law of fixed proportion. Is it okay, everybody? Yes, please.
Yes, sir.
Yes. So please write it. So this is what it is. So once you understand this, then we'll proceed further. Any doubt? Anybody can ask. Till here, any doubt? Please don't be late. Abhirami and Divya also I'm saying. Divya, understand Divya? So please say yes or no. So always in a given compound. Suppose if you take water. What is the ratio, guys? Always hydrogen, 2 hydrogens and 1 oxygen. That is what atomic ratio. But what is the mass ratio? Anyone can tell? Mass ratio. We all people knows. What is the mass ratio? 2 into 1 is to 1 into 16. So which is equals to 2 is to 16. So divided by 2. So 1 is to 8. So this is a mass ratio. Mass ratio is always remains constant. Mass ratio is always remains constant. Suppose they'll ask you what is the mass of hydrogen. What will do, Hari? Mass of hydrogen. Mass of hydrogen in water. Mass of hydrogen means what will do? 1 by 9. Understanding? 1 by 9 into 100 mass percentage. Okay. Next, if they'll ask you oxygen percentage, what will cut? 8 by 9 into 100%. So that is what you have to do it. Okay, guys? Yes, please.
Yes, sir.
Yes. So that is what you have to remember. Sir, how you will get 9 here? How you will get 9 means here, remember, that is what concentration of solute we are solving. Mass of solute divided by mass of solution. So mass of solution means here 1 plus 8. So 1 plus 8 is equals to 9. So if they'll ask hydrogen, 1 by 9 into 100%. They'll ask oxygen, 8 by 9 into 100%. Is it okay, everybody? Yes. Please
Yes, sir.
respond. That is what. So this is what is postulates of Dalton's atomic theory and the explanation of Dalton's atomic theory of laws of chemical combination. How a laws of chemical combination is explained by Dalton's atomic theory. Now, if you'll observe very carefully, as we know, this Dalton has given so many laws, so many postulates of this one, as we already studied. Now, is there any drawbacks of this one? That is what we are going to study now. So, by the time of Dalton's, there is no kind of electrons, protons, and neutrons. They don't know that atom is also made up of 3 subatomic particles called as electrons, protons, and neutrons. So he said the first statement. All of you read. What is the first and second statement, Mr. Harish, Mitaksri, Akilan, all of you? What is the first and second statement? Every atom, every matter is made up of smallest particles. What is that called as?
Atoms.
Atoms. And he said that atoms are the smallest particle which cannot be divided further. Is it yes or no, guys? That is what we can say. Atoms are indivisible. Is it true or not? Yes or no? But it is wrong. So that is what disadvantage, or we can say drawback. Very, very important, guys. So please write drawbacks of Dalton's theory. Dalton's theory. So Dalton said that atom is indivisible, but is it wrong or not? Yes or no? Yes or no, all of you? So Dalton
Yes, sir.
said that atom is indivisible, means it is not possible to divide the atom, because by the time they don't know electrons, protons, and all, guys, that you should remember. Indivisible means cannot be divided, but later it has been happened. We people can divide the atom also. Individual electrons we can remove it from them. So it is made up of subatomic particles. So it is wrong. Drawbacks of that one. Dalton said that atom is indivisible, but atom is made up of what, guys? Made up of subatomic particles. Who is the subatomic particles? Anybody? Who is the subatomic particles? All of you. Who is the subatomic particles of atoms? Nobody? Electrons. Yes. Gokul. Electrons, protons, and as well as neutrons, which discovered by scientists. Later on. Means Dalton times he don't know. That is why he said it is not possible to divide further. But now we people can divide the atom also into like we can say like removing electrons, removing protons, and whatever it is, we can convert it into some other form. So that is why it is becoming a disadvantage. Are you clear, Divya, Abhirami, Gokul?
Yes, sir.
The disadvantage. Next, Mr. Dalton said something regarding mass. Can you tell me, everybody? Is it mass of every element is same? Is it mass of every element is same? Yes, please. Suppose if I'll take carbon, if I'll take oxygen. So carbon atom and oxygen atom, is it mass is same or different?
Different, sir.
Different mass. But I will take carbon and carbon. Now, is it same or different? Hari? Yes, please. Same mass or
Same,
different
sir.
mass? Yes or no? Same mass. That is what said by Mr. John Dalton, but it is also wrong. All of you remember, different atoms may have a different mass, but same atoms will be having the same mass, he said. All of you remember that, but it has been proved wrong. So all of you read fifth point and sixth point, fifth point and sixth point in Dalton's atomic theory, fifth and sixth point. Everybody should read. Yes, please. Read outside. Fifth and sixth point. All of you. Aswin. I'm asking you only, guys. Read fifth and sixth point. Mitaksri, you read Mitaksri. These fellows, useless fellows, they'll never understand. Read. What is the fifth and sixth point? Atoms are of various kinds. Sorry. All the atoms of a given element are identical in every respect, having the same size, same mass, and as well as same chemical properties. And atoms of different elements, different mass, different size, and different chemical properties. That is what Mr. John Dalton said. So if you take atoms of a same element, John Dalton is saying that atoms of a same element, they'll be having the same mass. That is what Mr. John Dalton said. If you take a different atoms, definitely they'll be having a different mass. But if I'll take, we'll study in the next chapter. After discovery of isotopes, I will teach you what is this. Isotopes, this, even though the atoms of same elements having atoms of same elements also having different mass. Sir, how, sir? For example, let us take chlorine atom. So chlorine basically present in two forms. That is what I will say isotopes. Isotopes means same number of protons but different number of neutrons. That is only called as isotopes, which we'll study in the fourth chapter. So remember, it is a disadvantage. For example, if I take chlorine, what is the atomic number? Anybody can tell what is the atomic number of chlorine? Harini, Harish, Gokul. Chlorine atomic number, you might be don't know. Chlorine atomic number is 17. Chlorine atomic number is 17. All of you remember. Means 17 protons are present. Okay, everybody? Yes, please. 17 protons are present. So, if I take the chlorine, basically, chlorine is existed like this. 17 protons, atomic number, and mass number is 35. One more chlorine if you take, chlorine can present in same number of protons, but 2 neutrons extra. So that is what we will say. 2 neutrons extra means how much it will come? Anybody? How much it will come? 37 will come. Understanding? Here, 2 neutrons are extra. Neutrons can be extra or less, but protons cannot be changed. Protons always same for every atom. Okay? So, if we'll take here, if I'll take atom from this and atom from this, so having same mass or different mass? Same mass or different mass? Everybody? Different mass. So, that is why it is a drawback of Dalton theory. Dalton said atoms of same element having same mass, but if we'll take the isotopes having different mass, even though the atoms of a same element, they have a different mass. So that is what it is a disadvantage. Is it okay, guys? Yes, please. Please respond. All of you?
Yes, sir.
Yes, sir.
Okay. Now, what is the, you can take, what is the meaning of isotopes mean?